Hello. What I would like to do today is show you how to solve problems with a 30, 60, 90 triangle. As you do these problems, the first thing you have to do is recognize that you have a 30, 60, 90 triangle. So as you look at this triangle, it's a right triangle. I know it's a right triangle because of the 90-degree angle. I know that it's a 30, 60, 90 because this angle is 30 degrees and this angle over here is 60. Now, it's helpful to know what each of these sides are. So let's start with the obvious. This is my 90-degree angle. This is the biggest angle in the triangle. So the side opposite the biggest angle, which is this side over here, is the hypotenuse. Hypotenuse. Now, when we look at 30 degrees here, opposite the 30 degrees, this is the shortest side. But when we look at it as a right triangle, we can also say that this is the short leg. These are both legs, and I know this leg has to be shorter because it's opposite the 30-degree angle, and that's smaller than 60. So the short leg. And we like to abbreviate this as SL, the short leg. This side over here is what we call the long leg. Long leg. And what we spent some time doing is we talked about the relationship from the short leg to the hypotenuse. And we learned that the hypotenuse is equal to the short leg times 2. That's the hypotenuse. And we learned that the long leg is equal to the short leg times root 3. This is always the case in a 30, 60, 90 triangle. And we experimented with this in class, so we know that this is true. So now let's take a look at some example problems. If I know that this side over here is 5, and I want to find the hypotenuse, and I want to find the long leg. So I know the hypotenuse is going to be the short leg times 2. And in this case, we know that this has to be the short leg because it's opposite the 30-degree angle, the smallest leg. So this is going to be 5 times 2, and 5 times 2 is 10. So I know this hypotenuse is 10. Now what I would like to do is find what the long leg is. And the relationship with the long leg is that it's equal to the short leg times root 3. And that is always the case. So we have our short leg is 5, so this ends up being 5 root 3 is what the long leg equals. All right, let's look at another example. My next example, let's um, look at a bigger number. Let's look at 11. So if the short leg is 11, I want to find the hypotenuse, and I know the hypotenuse is equal to the leg. You know, I wrote leg, but let's be more explicit. Let's call this the short leg times 2. So what is my short leg? It's 11 times 2. So now my hypotenuse is equal to 22. So this length here is 22. The hypotenuse is always going to be twice what the short leg is. Okay, so now what I want to do is find the long leg, and I know the long leg is the short leg times root 3. I know that the short leg is 11, so this ends up being 11 root 3. All right, let's look at a little harder example. If I tell you that this side over here is the square root of 7. Okay, so now you have to ask yourself, well, what side do I have? This is the short leg. And I want to find the hypotenuse. I know the hypotenuse is the short leg times 2. So if the short leg is root 7, then the hypotenuse is going to be root 7 times 2. Now, what you have to be careful is when you multiply these two together, 2 isn't under a radical sign, so we can't multiply the 2 and the 7, so we would write our answer as 2 square root 7. Now some of you might be saying, okay, well why can't I just keep the 2 here? And it's just a normal practice that we, in math, put a number that isn't under the radical sign. When we're multiplying, we put it in front, because when you have it back here, it can accidentally get put into or under the radical sign, and we don't want that. So this is a little more clearer communication. So we know the hypotenuse is 2 square root 7. Now, we're not done yet because we want the long leg, and we know that the long leg is equal to the short leg times root 3. So if the short leg is the square root of 7, this equals the square root of 7 times the square root of 3. So now we're multiplying two numbers that are radicals, so we can multiply what's inside. So what's 7 times 3 is the square root of 21, and that's what our long leg equals. Now, from what our practice in class, if we could simplify the square root of 21, we would, but in this case we can't. So our long leg is just the square root of 21. Let's take another look at another example, and let's do the square root of, let's say, 13. And I know this is the short leg because it's opposite 30. I know that this is the hypotenuse because it's opposite 90, the 90-degree angle, and we know that because it's a 30, 60, 90 triangle, the short leg is times 2. So in this example, again, we know that the short leg is the square root of 13 times 2. And again, 2 isn't under a square root, so this ends up being 2 times root 13. So our hypotenuse is 2 times square root 13. Now the last part that we have to do in this example is we have to get what the long leg is. And the long leg is equal to the short leg times root 3. We know that the short leg is the square root of 13, so we know the long leg is going to equal square root 13 times the square root of 3. So then we know that the long leg is going to equal, now we need to think about this for a second, they're both under a square root, so we would take 13 times 3, which is 9, and 39. So then this ends up being the long leg is the square root of 39. Again, if we could simplify the square root of 39, find a perfect square in it, we would simplify it. In this example, we can't. So this concludes my tutorial on solving 30, 60, 90 triangles. Thank you.